The second law of thermodynamics states that the entropy of an isolated system does not decrease or always increases. Processes that proceed in a definite direction without energy input are spontaneous, and processes that cannot go back to the initial states are irreversible. Talking on irreversibility, second law of thermodynamics presents the arrow of time. The thermodynamical time arrow is an arrow on a macroscopic scale pointing in the direction of increasing entropy. Things cannot go back like they were. Spontaneous and irreversible processes increase the entropy of a system. Diffusion is the random thermal motion of the particles from region of higher concentration to lower concentration. It occurs via Brownian motion, which is the random thermal motion of all particles at temperatures above absolute zero. The moving particles are self-propelled by thermal energy. Diffusion is a spontaneous process as it happens without any energy input but only driven concentration gradient. The transfer of kinetic energy involved in the collision causes a shift in the velocities of both particles. The net result is each particle seems to be moving in a random fashion. Energy dispersion occurs and leads to increase of the entropy of the system. We are going to show 2 experiments on diffusion. This experiment is done to prove that diffusion happens randomly. First, prepare 2 beakers of water with the same volume at the same temperature. This is to make any possible parameters to be constant. Then, dip in the dye slowly into the beaker simultaneously. Through the experiment, we can observe that the moving pattern of the dye in the water is different in both beakers with the same amount of dye dipped. This also shows the matter dispersion during the process, which leads to increase of entropy of the system. Let us fast forward to see the end result of this experiment. After 5 minutes, both beakers contain evenly distributed blue solution, but obviously the paths taken by the diffusing particles are different. And this is what we call the randomness of the process.
We have 2 beakers here, which is beaker A and beaker B.
The first beaker will record temperature of 30 degrees Celsius, while beaker B will record a temperature of about 90 degrees Celsius. Similar to the first experiment, 2 beakers of water are prepared with same volume of water. Then, dip in the dye slowly into the beaker simultaneously. The only manipulating variable is temperature. We can observe that beaker A shows a lower rate of diffusion while beaker B shows a higher rate of diffusion. Second beaker takes a shorter time for the beaker of water to turn evenly blue compared to the first beaker.
2 evenly distributed blue-colored solutions are formed, but at different rates.
As mentioned earlier, the particles are propelled by thermal energy, so the experiment proves that higher energy possessed by the particles do increase the rate of diffusion. The distribution of the solute molecules becomes randomized throughout the entire system. Thus, entropy increases.